Hi everyone, welcome back to Art of the Part. Today we're going to start our discussion on SolidWorks Assemblies. This is going to be a couple different topics. We'll eventually get to this point where we can make an exploded view and then make a drawing from that so you can give it to somebody out on the shop floor. But the first topic that we're going to talk about with this video is primarily going to be about SolidWorks assembly file types as well as a couple basic mates. So we're not going to get all the way through this lesson in just one go here. But I'll just show you what this looks like collapsed. And I'm going to close out of this assembly and start our discussion on the hierarchy of files in SolidWorks. So you can see here we have a couple different icons that are presented to us when we start a new file or new part. But you'll notice that we had done the part level in a previous exercise with the 98431. It was a collection of sketches and features that go from 2D to 3D. And then we went and skipped the assembly icon here and went straight to the drawing because we wanted to make a blueprint for that specific part. So you can export that as a DXF, DWG, or a PDF and then send that out for manufacturing. Well, we can also take a part and then use multiple parts and bring them into this assembly icon. And you'll notice that the assembly icon is a little different than the part icon because instead of it just being the singular Tetris piece with the yellow coloring, it's going to be the yellow Tetris piece with a blue block here. And that just tells us that we can bring in multiple components into one single file and see if there's any clearance issues or interferences that we need to watch out for. So let's go ahead and start up a new assembly and hit OK. And you'll notice that whenever you start a new assembly, it's going to ask for you to locate a part or multiple parts to be imported with this insert component. So I'm going to go ahead and find this file or collection of files. You'll be able to download this from the Google Drive, but it's going to be the vise and riser. And there's going to be 3D file parts that we're going to reference. So I talked about 3D files and the different types of imports and exports that we can handle inside of SolidWorks in a previous video. So I'm just going to briefly talk about that now as well. You'll notice that when you're in the file folder, it's going to be like Vice and Riser for students, something along those lines. I'm going to be locally looking for SolidWorks files. And you'll notice that there's nothing available to us. Well, in a previous video, I talked about, IGES files, Parasolid files, step files, so on and so forth. And whenever you're purchasing equipment from manufacturers, there's a good chance that they're not going to be using the software that you're using. So they oftentimes will export a dumb solid of it, whether it be in a Parasolid or a step file or an IGES file. So I have to then change the file type that I'm looking for to all files. And you'll notice that I now have a collection of files that are available to me. So I'm going to look for this 5-axis riser. So this is the first part of this whole assembly. I want this to be the origin of my assembly moving forward. So there's going to be a problem here, but when I click on this and hit open, you'll notice that it says file name entered was invalid, not found, locked, or of an incompatible type. So this is kind of like what I was talking about in that previous video, where if you try to open up another native parametric modeling part in another software, well, you might have these compatibility issues. Well, same thing is happening here. SolidWorks Assemblies will not actually recognize dumb solids. You have to force them into being a native SolidWorks part before they can be imported into the assembly itself. So we're going to hit OK, and we're just going to minimize this assembly window really quick. We're going to come back to it in just a second, but we'll go to the File Explorer and we'll locate where these files are, and I can just drag and drop these files into the SolidWorks home screen like I've done before in other videos. So I'm going to click on this 5-axis riser here, click, hold, and drag, and then drop. And again, you'll be prompted by this, do you want to run import diagnostics on this part? You always want to hit yes, make sure that there's no interferences or missing gaps or anything like that. No faulty faces or gaps remain in the geometry, so I'll be able to hit the green check mark. And then again, I'm encouraging you not to hit feature recognition on this one because there are a handful of different drafts, extrusions, cuts, holes, and then likewise this text here that's going to have to be rebuilt. And I'll tell you from firsthand experience, trying to figure out this text is going to be a nightmare for SolidWorks. It's much better to kind of do that on your own. So I'm going to hit no. I'm going to leave this as a dumb solid. You'll notice here on the import, it's just one solid body there. So I'm going to start a new file folder when I save this so that I can collect all these native SolidWorks parts to then be imported into the assembly. So I'll go to File, Save, and then in this Vice and Riser for students or wherever you're working out of, I'm just going to make a new file folder by right-clicking in the area here, and folder, and I'm going to name it completed, caps lock, completed Vice and Riser assembly. And then I'll just double click on that file folder, and then I'll save this just the way it is. So this file name here, it has the part number, which is helpful because what we're gonna probably do in the future is either purchase another one of these or wanna have it on reference so that we can include it with our bill of materials. So I'm not gonna change anything in this so that when it pulls into that bill of materials, I do have that reference part number there. So just gonna hit save. And you'll notice that it's no longer just a part one, it has the part name up there. And I could now, in theory, move this into an assembly. So I can either file, make an assembly from part, just like what we've done before, but I already have an assembly open in the background. I'm going to teach you how to toggle between these windows because we'll be doing this a handful of times as we move through this lecture. So you can either go into Window and open up that assembly that we initially started, or I like this better, but if you hold down the Control key and you use the Tab button, you'll actually toggle between the different files that you have open in SolidWorks. So I'm going to go over here to Control and Tab over to the assembly that I'm working on, and then I'll go over here to Insert Components, and inside Insert Components I'll be welcomed by this little window here where I can find any files that I have open in the background. So I'm going to click on this 5-axis riser. You'll notice that it's attached to my mouse right now. And I'm going to show you a bad example, so just don't follow this specific point here. Go ahead and watch me, and then I'll tell you when we can kind of do this again. But it's tempting just to drop this anywhere into the 3D space, just because it's attached to your mouse and you want to get rid of it. Well, what happens is if you accidentally click over here, for example, well, the origin isn't going to be locked or linked to the initial part. So if I click on the origin inside my assembly, you'll notice that it's way down here on the bottom left of my part. And that's not going to be helpful because if I start toggling over some of these different planes, they're not going to be in reference to this part that I'm building my assembly off of. So I'm going to delete this, and this is where I want you to start following me again. So Insert Components, we'll click on this part, and instead of just dropping it out in the viewport, I want you to get in a habit. If there's one thing you remember from the SolidWorks exercise with assemblies, you always want to start off your first part by using this OK. So don't click out here, just select the part and then hit the OK or the green check mark. And what this is going to do is it's going to lock and link the origin to that part. And this is very helpful in the automotive and aerospace industry because if you have big components and big assemblies that have 100,000 different parts, bolts, washers, control arms, you name it. You want to make sure that they're all linked to a single origin because if I'm sending this to somebody on the other end, well, they can just go through that insert component process and continue to select the part, hit the green check mark, and it's going to rebuild that assembly piece by piece without me having to manually go in and mate things together. That's helpful in that specific scenario. We're going to deviate away from that because I want this to be my initial origin and then build from there. So the next thing I'm going to do is import the vise itself. And you'll probably remember from our experiences before that I can't actually import the dumb solid into the assembly. So once again, I'll have to minimize this window and I'll have to minimize, or I can actually close this part window here. I'm just going to close it so that it's not interfering with anything. And I'll be back here in this SolidWorks home screen. So I'll open up my File Explorer again, and I'm going to go find my Shunk KSC grip. Click, hold, and I'll drag and drop that out here into the home screen as well. And you'll notice that this is a little different than the first part that we were referencing, that riser. So instead of it just being one body, it's actually an assembly. So you can tell that by that little icon, the little yellow Tetris piece with the blue square, with all these other different components or parts that are embedded into this dumb solid itself. And this is helpful because if you want to export an assembly the way that you're seeing it, well, you can do that. You can just make it a parasolid or a step file and then include all those components in one file. Instead of it, especially if you had like an assembly with like 100 different components, you could just flatten it into that one file with this step export. But the problem is that these files are now all locked together. They can't be moved. They're all fixed in place. And you can see that they're fixed in place because they have this little lowercase f next to every one of these components. But before I can even start messing around with that, I have to make native SolidWorks components from this assembly. So you might have to go in and open every single one of these and save them individually. But if you want to save time, you can go ahead and just go to File, Save As. We're going to locate that completed vise and riser assembly. And this is very important. This is going to save you a lot of time if you have a bunch of these components that you have to save natively. Well, you just click on Include All Reference Components, which is located right here. So I'll click on Include All Reference Components, and then I'm going to click Save. And you'll notice that if you go back to that file folder, I now have a bunch of different files that were populated from that assembly. So I'm going to go ahead and Control-Tab over to my assembly window and pull this subassembly in there. So I'm going to hit Control and Tab. I'm going to go back to this screen here, and I'm going to go back into Insert Components. So then I'm going to click on this chunk grip, and I'm just going to drop this out here. I know it would be tempting to hit the green check mark, but see what happens when we hover over that green check mark? Well, it's locking that vise inside the riser, which isn't going to be helpful for us. So I'm going to go ahead and hit the or drop the part out here in 3D space, and then I'm going to align it and then break the subassembly. So if you guys remember from days of old, we used to have a function inside of Microsoft Word called Clippy. And this little icon would show up and tell us, hey, you haven't saved in the last 20 minutes, or I think you mean to spell it this way. Well, we have our very own Clippy inside of SolidWorks, which is going to be called the mate feature. So that mate feature is going to lock and glue components together so that we can make sure that they're fixed and they don't move around on us on accident. So I'm going to show you this first basic mate. So I'm going to click on Mate right up here inside the Assembly tab. And then I'm going to do a couple mates here. I'm going to show you the basics of mates, and then we'll kind of stop there and we'll start another video and show how to break this subassembly here. But first and foremost, we talked about degrees of freedom in previous lectures where you have to have at least 3 to lock down a part. And in the same theory or function, we have to have 3 mates to make sure that that part is fixed. So I'm going to select inside of this blue mate selection box, and I'm going to choose the face here. So you'll notice that as you hover over geometry, you're going to get either an edge or a surface or a face. So I want to make sure that I'm selecting the face or the top face of this riser. Anywhere on it, it turns blue. You can see everything that you selected. And I'm going to select the bottom face of my vise. So you'll see that they linked together now. Well, I can hit the green check mark over here in this quick toolbar, or I can hit the green check mark over here in the properties bar. And just like what we talked about before, SolidWorks kind of acts like a machine gun or a Gatling gun where it's going to continue firing until you let off that trigger, right? So it's going to continue on with this mate function until I either hit the escape key or hit the X key here. Well, I want to be able to add more mates here. I don't want to keep going and clicking on that paperclip over and over again. So I'm going to keep this active. And one convenient thing about SolidWorks is that even though that you're in the mate function, I can move things around to access certain geometry. So for example, I want to make sure that there's a hole underneath here that is in line with a hole that's underneath here. Well, I have to move this to access that piece of geometry. So I'm going to click and hold on my vise, and if I click, hold, and drag it somewhere else, well, you'll notice that even though I clicked on it, it didn't actually populate a mate in that mate selection. So that gives us a lot of power in accessing different geometry when we're mating things together. Now, with this specific mate, I want to make sure that this hex key is in front, so in line with this shunk logo here. So I have to go underneath, and I have to select the surface of this hole. So I'll click on the surface of that hole, or that face there, and then I'm going to grab the surface of the hole here. So there's going to be a concentric mate that is applied. And then I'll hit the green check mark. And SolidWorks does a really good job, and you're probably not noticing it as you're doing it, but it recognizes what those two pieces of geometry are, and it tries to pick the best solution of what you want with that mate. So for example, that first one, I didn't even notice, or I didn't even talk about it, but you probably didn't even notice it, but it made a coincident mate. So the next mate that we're going to do is, this is our last mate because we have 2 degrees of freedom. We can still move it around. We're going to pick the smaller, or the inside hole rather, the hole that's closest to the center, and we're going to choose this hole right here as well. So we'll select this hole, the surface or the face, and then we'll select this surface right there. And then I'll be able to hit the green check mark. And you'll notice that I have 3 mates that are now shown below here in this mating properties bar. And if I ever accidentally clicked on the wrong surface or something, I could always right click and delete or clear selections, or I could delete a mate here in this window as well. But this is just showing you all the mates that are currently present in this current mate function. So I'm going to end it right there. I'm just going to hit the green check mark and hit the green check mark again. And I want you to try moving this part around. So we'll notice that it's totally fixed if I try to click, hold, and drag. And we're at a good point where we can start breaking up this subassembly. So I'm going to save this and end it right there. So File, Save As, and then locate that file folder that you were working in. So I think that was in my documents. And then I'll go in here and I'll just title this Completed Vice and Riser Assembly. And then we'll hit Save All. And we'll continue on in the next video about breaking this subassembly.